A transformation is a rule that assigns to each element of a set a unique element of another set. A transformation T of Rn into Rm is a rule that assigns to each vector u in Rn a unique vector v in Rm. Rn is called the domain of T and Rm is the codomain. We write the transformation of vector u equals vector v, where vector v is the image under T. The term mapping is also used for transformation. So within the concept of transformation, we will first discuss dilation. Consider the transformation T of xy equals the scalar r xy, while r is a positive scalar. T maps every point in R2 into point r times xy as far away from the origin. If r is greater than 1, T moves r points away from the origin and is called a dilation of factor r. This equation can be written like the following using matrix form. T of xy equals the matrix R0, 0r times vector xy. For example, when r equals 3, we see the following equation that an image is 3 times away from the origin. So you have just seen an application of the transformation concept dilation where Super Mario eats a mushroom and expands in size. His original state can be represented as a matrix A, B, C, D, and the scalar R and S represents changes in height and length respectively. So we perform the following transformation of matrix A, B, C, D, and vector RS to result in the matrix RA, SB, RC, and SD, which can be notated as a matrix EFGH. Notice how matrix ABCD is transformed to matrix EFGH using the concept of dilation, where R and S are both greater than 1. Consider again the transformation T of xy equal to R of xy, while R is a positive scalar. Recall, if R is greater than 0 but less than 1, T moves closer to the origin and is then called a contraction of factor R. For example, when R is equal to 1/2, an image is half the distance from the origin. T of xy equal to the matrix 1/2, 0, 0, 1/2 times vector xy is also equal to 1/2 times vector xy. So the same application can be applied to the transformation concept of contraction if Super Mario was to decrease in size. His original state can be represented as a matrix A, B, C, D, and as scalars R and S, which represents the height and length changes respectively. So we perform the following transformation of matrix A, B, C, D, and vector RS to result in a matrix RA, SB, RC, and SD, which can be notated as matrix EFGH. Notice how matrix ABCD is transformed to matrix EFGH using the concept of contraction, only this time R and S are both greater than 0 but less than 1.